since the mass eigenstate are combination of flavor eigenstate themselves, this difference in speed cause interference between corresponding flavor component of each eigenstate. Dah. Dia dengan dia pula berinteraksi. Because you know, for different flavor, they boleh superpose. Constructive interference cause it to be possible to observe neutrino created with a given flavor to change its flavor during propagation. So the probability that neutrino originally of flavor alpha will later to have flavor beta is, so this is using the probability of flavor changing, say from alpha to beta. So this is given by the P alpha to beta is equal to, this is just from quantum mechanical viewpoint, just the convolution of the beta state, which is the final. Kita tulis final dulu, lepas tu convolute dengan yang asal, of course at given t, and we square the convolution, and this is just convolution ni maknanya apa? U alpha I star, sebab dia di sebelah kiri mestilah star, and then U beta I, E minus I mi square L divided by 2D whole thing square. This is for given, so even though this is flavor, tetapi kita expand dari segi mass state. Okay. And where does the transformation calculated by this amplitude of alpha and beta? Okay, so you explain alpha and beta, apa ni? That square there, amplitude square. Kita continue di sini. You can break it into two parts. So this, I better write it B alpha becoming beta. The continuation, continue here. You can have this delta function, meaning what? It will be 0 if alpha not equal beta. That's okay. If it is not changing, because it is oscillating with distance, so there is a probability that when you measure it come back to its original flavor. That's why I'm writing this. Why I write this? Because there is possibility that oscillate, nanti dia balik pada asal. So I'm writing this. Now, so now you expand that, and there are 4 terms there. For I greater than j. So that is the real part of U alpha I star U beta I U alpha j U star beta j, and the exponent is written in terms of sine and cosine. Itu yang jadi panjang ni. have the imaginary part. So the square of that U alpha U beta adalah di square, ditukarkan pula eksponennya dalam sebutan sin cosine. Saya sendiri tak ingat sin cosine itu macam mana tapi if you do the correct the correct replacement or correct formula, you will get this. U alpha j star beta j sine delta mij square L divided by E, where delta mij square is actually mi square minus mj square. So now you have to take care of units because the sign or what's inside the sign is dimensionless. So if we put the C and the H bar, which we equal to 1 just now, putting C H bar, so we have delta M square C cube L divided by 4 H bar E. So this is the one inside the sign square. So this actually equal to 1.27 delta M square, which is in EV square, L which is in kilometer, GeV E. So the energy is in GeV. Now you can make an estimate from experiment. Estimate says that delta M square is of the order of 1 times 10 minus 4 EV square. Okay. The masses between the the difference in the mass of the muon neutrino, tau neutrino, and electron neutrino is about of this order, quite small. And oscillation from experiment L is of the order of a few kilometers. And energy depend on the source to produce neutrino. So this energy of the neutrino is of the order from MeV if it come from the reactor source, or GeV if it come from the sun. Sorry, MeV from reactor and the sun, and GeV from if you do some high energy experiment. Now, there is 3 terms here in this probability. If there is no CP violation, the third term 0. The imaginary part becomes 0. If there is no CP violation or delta 0, then second term, the second summation is 0. Then this imaginary blah blah blah, right? I get the J is 0. But on the other hand, if there is a CP violation, you can define a CP asymmetry term, which is the if there is CP violation, then we can define CP asymmetry. CP asymmetry measure, which is so A is CP asymmetry. CP alpha beta is just the two flavor, say muon to tau, or alpha to electron to muon, or electron to tau. So this is equal to the probability of new alpha becoming a new beta minus the probability of antineutrino alpha changing into antineutrino beta. And if you do the calculation, it will be 4 times the second summation, which is twice that I get the J imaginary part, or U alpha I star, U beta I, U alpha J, U beta J star, sine of the delta Mij square L divided by 2E. Okay. So you can actually calculate for any two neutrino, you can calculate this. Sometimes people try to rewrite this neutrino oscillation in terms of harmonic oscillation. If you consider only 2 lah, tapi in reality dia punya oscillation into 3. Yeah. So electron neutrino ni boleh jadi muon dan tau, bukan jadi muon aja atau tau aja. Tapi kalau if you want to really understand it, you can put into a model of harmonic oscillator. Yeah. So in term, you can for any two, for any two neutrino flavor, that is alpha beta, you can model oscillation using simple harmonic oscillator. Ini untuk pemahaman. And usually this model not quite correct. Well, I mean, you have a pendulum mass 1, another pendulum of mass 2, and there is of course angle of theta 1, theta 2, and it's connected by spring of spring constant K. Of course, the length is also different. The length of the string is L1 and here L2. Okay. So these pendulum are coupled via a spring. So of course, in reality, you can. This is what you call it, neutrino 1, neutrino 2. Any two neutrinos, you can model like that. Of course, the potential energy you can write immediately for this couple pendulum. Harmonic oscillation, but couple, okay? Not individual. Then the potential of a couple pendulum can be written as but here you have to do some assumption, which is probably not so correct. Let M1 near to M2. Otherwise, the analysis will be very complicated. So we assume that the mass of the neutrinos are not very different. So then you can write it as M/2 G L alpha, length of the alpha H. Instead of alpha, let's use A and B. Oh, yeah, alpha. So this is a quadratic form of the couple pendulum. What is XA, XB? It is the displacement. Displacement from the vertical. Can be written in terms of in matrix form. So it is it can be diagonalized actually. there is an angle. There is an angle, and here this angle will show the mixing property, even though it is mechanical modeling. There is an angle where you can write x alpha, x beta in terms of cos theta, sin theta minus sin theta cos theta, x1, x2. Then you rewrite the potential of interaction as m over 2 x1, x2. So you rewrite, then you have lambda 1, 0, 0, lambda 2, x1, x2, where lambda 1 and lambda 2 are the eigenvalues of the matrix. Eigenvalues of the cos theta, sin theta matrix. So we will see that transforming from XA, X alpha, X beta to X1, X2 describe normal mode with oscillation of frequencies equal to root lambda 1 and root lambda 2. When the two pendulums are identical, in other words, L alpha equal to L beta, theta will be at 45 degrees. So this is analogous to Cabibbo angle. So this very brief analysis, x1, x2 can be called a kind of a normal modes. Why normal modes? Because we can diagonalize. And what is the frequency of oscillation of these two pendulum? So M1 oscillate with frequency square root of lambda 1, and M2 oscillate with frequency of square root of lambda 2. So this between two neutrino you can consider it still oscillate, but now since it interact with the mesh, yeah, and neutrino, electron neutrino and muon and tau interact differently pula. Yang tadi just ada mesh yang lambat, ada yang cepat, okay? So itu satu hal. Sekarang kalau dia berinteraksi, maknanya dia travel in some medium, bukan saja lambat dan cepat, tapi cross section of these different cross-section interaction of these different neutrinos interact differently with the medium. Itu dah lain pula. So in the case where the oscillation travel in medium, taking care of the interaction of the neutrino with the medium, itu dipanggil MSW effect. Mikhaev-Smirnov-Wolfenstein effect. That is the modification of the neutrino oscillation in matter. So nanti kita, kalau ada masa kita bincang lah. But basically, even in vacuum dia oscillate. Tak perlu in medium. Kat medium dah tambah lagi complexity dia. Maknanya kena ambil kira cross section of interaction of the different neutrino pula with the matter. So itu kata orang tu memeningkan lagi lah. So anyway, so we don't need to discuss the MSW effect lah. Cuma kamu boleh baca lah kalau kamu minat. So I think in the next class I will try to finish off for the next class treating the idea of grand unification, okay, the idea of string theory, and finally the idea that we might have a theory that go beyond the standard model to explain so many things that is not explainable by standard model. Contohnya the idea of supersymmetry, the idea of nak gabungkan dengan gravity dan sebagainya. So you have to go beyond. One of these ideas is of course string theory, or now membrane dan sebagainya. So this is just an idea. And then the other thing is going to higher dimension pula. So space-time might be consists of higher dimension. So this can only be probed at high energy and so on. So we will give those things, and then kelas lagi satu, ada 2 lagi kelas. Yang terakhir mungkin kita buat latihan lah kelas 4. Gantung pada schedule kamu lah. Takut ada langgar dengan apa tadi?